All right, so today we're going to learn the first way that we can find a solution to a system of equations. Okay, there's three methods that you're going to learn to do the same exact thing. The first method is graphing. Okay, so again, we're just going to kind of recap what a system of linear equations is. It's two or more linear equations. Now, for pre-algebra, we're only going to do two. Okay, two or more linear equations with the same variables. The variables have to mean the same thing. The solution to a linear equation is an ordered pair that can make all the equations in the system true. Okay? So we're looking for an ordered pair. That's going to be our solution. All right. Okay. So in example 1, this should look familiar to you. To graph a linear equation. So look at the first equation, y equals 2x plus 5. All right, now you just took a test yesterday, right, where you graphed an equation in slope-intercept form. Go ahead and put your first point on your graph. Where would your first point go on your graph for that equation? Okay, where does your first point go? Vivian, can you tell me? Where's your first point go? Don't know? Jada? On a y value of 5. The last number in my equation, guys. So look up here if you didn't know that. The last number in my equation is my b value, my y-intercept. You guys remember that?
Yes.
Y'all remember that? Okay. Now that I have my first point, I'm going to follow my slope to find my second point. But I only have one number. What is it over if there's nothing there?
1.
Over 1. You need to write over 1. Write it over 1. This is rise over run. Okay? So from that y value of 5, I'm going to rise 2 and run 1. Okay? Rise 2 and run 1. Now, I need you to use your badge, and you'll see why in a second. I need you to draw the straightest line that you can through these 2 points. Oh, that's not straight at all. Not the best day to drink caffeine. My hand is shaking. Okay. All right, so draw a straight line through those 2 points. Okay, now let's look at our second equation. Is the second equation ready to graph?
Yes, ma'am.
Okay, so it either has to be in slope-intercept form or standard form. This one is in slope-intercept, so I'm ready to graph it. Okay, where does my first point go? Y'all pay attention. Pay attention. Yes, it goes on a y value of -1. I always plot my first point where the last number is in the equation. Okay, and again, that's what you guys were tested over yesterday. All right, so plot your point on a y value of -1. Now, where do you go from there? What tells you?
Down 4 over 1.
Okay, the slope tells you. You go down 4. If there's nothing there, that means it's over 1. So we go down 4 over 1, plot our point, and now draw a line. Again, use the side of your badge or use some kind of straight edge to draw your line through those points. Okay? All right. So now I can see that these lines cross. Okay? The point that they cross, all right, I need you guys to understand this. It'll help you understand what in the world we're doing here in the first place. Would you agree that this point is a point on both lines where they cross? Remember what we said about the graph of a line. The line represents all the solutions to that equation. So what we're saying is this one ordered pair is a solution to both equations. Okay? So what is that ordered pair? Let's find the coordinates. -1
2
up
2
3. -1, and it goes up 3. Count it. Count it right there on your paper. You should have the same thing. Okay? So your solution is -1, 3. Okay? -1, comma 3. In parentheses, and you box it in. All right, now I put it down in the corner for a reason, because I want to show you why this is a solution. Okay? So this ordered pair, if it's a solution to the system, when I plug it back in for x and y into both equations, it will make both of them true. Okay, so let's test it. This is how you can check. All right, so -1, is that my x value or my y value? It's my x value. So you're going to plug in -1 for x, and you're going to plug in 3 for y. Okay, so that's what we're doing right now. We plug in 3 for y equals 2 times -1 plus 5. All right, and now we're going to see if that's true. What is 2 times -1? All right, so 3 equals -2 plus 5. What is, pay attention, what is -2 plus 5? 3. So is it true that 3 equals 3? Okay, so the ordered pair 1, 3 was a solution to this first equation. Now let's test it for the second equation. Okay, we plug in 3 for our y value. So we say 3 equals -4 times -1 minus 1. Okay, so let's see. Let's do the math. What's -4 times -1? Positive 4. Okay, negative times a negative is a positive. 2 negatives. 3 equals 4 minus 1. What's 4 minus 1, guys? 3 equals 3. So you see with the graph, now you don't have to do the checking. Okay, the solution is -1, 3. But the checking still works. Okay, the checking does still work. All right, let's look at the next problem. Any questions on this? Okay, so you're graphing a line just like you graphed in chapter 4, except now you're doing 2 and you just see where they cross. That's all you're doing. All right, let's look at this next equation, or system of equations. Y equals 2x minus 3 and y equals x plus 2. All right, are they both ready to graph?
Yeah.
Are they ready to graph? Yes, they are. But the second equation, there's no slope. There's no slope in front of the x, or is there? An understood 1 over 1. Okay? 1 over 1. Now, drawing your line straight is going to be really important. This one's a little tougher to get right on. A lot of students in second hour got the same answer, but then it wasn't exactly correct. Okay, so look at the first equation. I want you to try to be a step ahead of me on this. Look at the first equation. I want you to plot the first point on your graph. Go ahead and do that. Try your best to stay a step ahead of me. All right, y'all tell me, where did you plot your first point? -3. Okay, where did you go from that point? Y'all tell me. Where'd you go? Nope, not up 1. We're still on the first equation. Up 2. All right, Thomas, you with me on this? Okay, so from the -3, I go up 2 over 1. Up 2 over 1. And I plot my point. Okay, so up 2 over 1. And I plot my point. And I draw my line. As straight as I can. Oh, stink, man. That was so close, too. All right, I think it's close enough. I lifted off my pencil off the screen, and then it shifted a little bit. I still think that's pretty straight. All right, y equals 1 over 1x plus 2. 1 over 1x plus 2. Lila, where's my first point go for that second equation? Not on the 1. On the...
Oh, I mean 2.
Yes, on the 2. On the y value of 2 or the x value of 2?
The x value.
No. The y. The up and down one. The last number in the equation is your y-intercept. I saw you looking at that x-axis. It's not x, it's y. Okay, so up to a y value of 2. All right, did you guys get that? Did you get that point? Okay, where do you go from there? Up 1 over 1. Okay, now draw your line. It messed up. Hold on. Draw your line. Nope. Okay. All right. I didn't get it perfect, but it is really close. Okay. Where did yours cross? What ordered pair did yours cross?
7, 5.
6, 8 was the most common one. It's not quite right.
4, 5.
What is it? Not 7, 5, but 5, 7. 5, 7. Mine is pretty close. My first line was a little off. The solution is 5, 7. 5, 7. You got to get that line perfect. Now, once I teach you the other 2 methods, you're probably not going to want this one because there's so much variability between the lines. Okay? Now, thankfully, your homework is on big ideas. So literally all you have to do is plot the point, and it does the line for you. So it's going to show you clear as day where they intersect. So you don't have to worry about that. Okay? All right. So your solution is 5, 7. But if you got 6, 8, you guys are really close. Did you guys get something really close to 5, 7? Does your graph look really close to that? Yes? All right. Braden's looks good. Noah's looks good. Okay. Any questions? Any questions for me? Yes, Lila.
So I did mine. Mine didn't like intersect. Like straight across.
Okay, so your slope was probably wrong. Either your slope or your y-intercept was probably wrong. Did you plot a point on -3 for y down here?
Yeah.
And then did you go up 2 over 1?
Yeah.
And then 2 here and then up 1 over 1?
Yeah, I got it all right.
You got to keep going. If you keep going, they'll cross up there. Yeah, you just have to keep going with your lines until they cross. If you stop your lines, then they might not cross until, they're farther along. All right, we're going to do a third one. Okay. Is my first equation ready to graph? Oh, don't you dare fall asleep. I'm going to make you stand up. Okay? No sleeping. All right, come on. This is exciting. Okay, y equals 2x minus 2. That made it on the recording, by the way. All right, y equals 2x minus 2. Is that ready to graph? It is. Put it on the graph. It is ready. The second one's not. Okay? The first one is ready to graph, so you can go ahead and do that. Okay? Go ahead and graph your first line. All right, go ahead and start working on your second equation. Okay, I gave you a question like this on your test yesterday. Okay, so you should be at mastery to get these equations in slope-intercept. So go ahead and write this equation in slope-intercept. All right, try to get a little bit ahead of me. All right, let's see. Zoe, what would you do first on -x plus 2y equals -4? What would you do first? Yes, you would plus x. So we want to solve for y. Our heart goes around the 2y, and we add x to both sides. Okay? So now 2y equals, which term do I bring down first? x, or 1x, minus 4. Now I need one more step to get y by itself. What do I do? Hopefully you guys are a little ahead of me. Divide by 2. But wait a second. What am I dividing by 2 on x? There's nothing in front of it. 1. Okay, so y equals 1/2 x minus 2. 1/2 x minus 2. All right, so now I'm ready to get both of these on the graph. I go -2 for my point. Okay, now finish graphing them. I will say on an equation like this, there's no question what the answer is. If you get the points right, you're going to get the ordered pair right. Okay, so on a question like this, yes, graphing could work out well. All right, because of where the lines cross. All right, go ahead and finish putting your lines on the graph, and then I want you to write the ordered pair. Okay, so we're going to start at -2, then we're going to follow our slope. We're going to rise 2 and run 1, and then draw our line through. It's not very straight, but it's okay. All right, now we're going to do our second line. What did you notice about the second line? The y-intercept is the exact same number. So you're going to use the same point again, but now you're going to rise 1 and run 2. Rise 1 and run 2, and now your line goes through the other way. Okay, arrows on each end. So guys, what's your solution? What's your solution? 0, -2. 0, -2. That's where they cross. And they actually crossed on one of the points, so it makes it a lot easier to know what ordered pair it is. Okay? All right, we've got one more thing to cover. Okay? You're going to write your own system. Now, it seems a lot more intimidating than what it really is. Okay? I want you to remember, okay? Listen, shh. What 2 pieces of information, you know this, do you need to write your own equation? You need the slope and you need the y-intercept, okay? Let me give you another way to think about the y-intercept. That is your starting point. Isn't that the first point that we graph on a graph? That's my starting point, okay? So let's read this scenario, and I want you to think about which value would be my rate or my slope, and which value would be my y-intercept, or basically a starting point, okay? It says you observe heights of 2 plants for an experiment. Plant A has a height of 8 centimeters and grows 1 centimeter each week. So we're going to pause there, okay? We're going to use the equation y equals mx plus b. All right, so I want you to write that down. Y equals mx plus b. You need to decide out of that scenario, which one of these numbers would be a rate and which one of these numbers would be a starting value or just your beginning value. What do you guys think? Do you think 8 is your starting value, or do you think it's your rate? It's your starting value. That's how tall the plant is. All right, so we say y equals, we're going to skip the mx part, and we're going to say plus 8. Okay, now what did it say? It says it grows 1 centimeter each week. So that is the value connected to x. Y equals 1x plus 8. Okay, now I want you to do it again. Y equals mx plus b for plant B. Okay, I want you to do it again. I want you to try to plug in the numbers for plant B. So what's important with the system is that your x and your y stand for the same values in both equations. Okay, see if you can come up with your m and your b for plant B. All right, anybody want to tell me the equation they wrote? What do you guys think? Colin, what do you think? Well, do you know the rate? Look at plant B. It says it has a height of 4 centimeters, and it grows 2 centimeters per week. Look at how we set up plant A.
Y equals 2x plus 4.
Y equals 2x plus 4. That wasn't so bad. Y equals 2x plus 4. Now, if I were to graph these, could I graph them?
Yeah.
Absolutely. And could I see where they would cross? Yes. And that would tell me how many weeks. Because plant A started off taller, didn't it? But it doesn't grow as fast as plant B. So at some point, plant B is going to catch up with it. And they'll be the same height. All right. But we're not going to graph this one. I just wanted to set up our own system. Okay. All right. That's all you need to know for section 5.1.